Hello, everyone. Hope you all are doing great and staying safe at your end. Welcome to the day 3 of pre hackathon speaker session. The Python week will be hosting live workshops, talks, and amazing virtual hackathon, everything from 1st January till 10th of January. Moving on to the today's speaker session. This session will be all about playing with images and doing fun things around it. You will be able to understand what exactly the image technically is. How can you do the transformation in image like cropping, blurring, resizing, etc. This talk will also cover to detect edges of an image subject using Canny Edge detection. Lastly, we see how you can extract text from images. We will be doing all this using the OpenCV library. And with that being said, let me introduce you all to our speaker of the session. We have Bratin Kundu joining us. Bratin is
Hello,
software engineer
everyone.
at Gateway Technolabs, co-organizer with me at Mehsana Developers Club. We welcome you, Bratin, and look forward to your talk. Rock the stage.
Thank you. Thank you so much, Tirthak, for the kind introduction. And hello, everyone. Thank you all for joining in. And first of all, Happy New Year to everyone. Hope that 2021 is, will be the awesome for you guys. And definitely the start of 2021 is really good with this kind of event. So hope that you will be, very much be have good exposure to this event and this also has a following up with a hackathon. So really looking forward for you guys to kind of building some cool and amazing stuff with Python. So yeah, let's get started with today's session. uh, yeah, okay, thank you. So yeah, today we'll be talking about image processing with OpenCV. Before, uh, if you look at this title, image processing with OpenCV, so it has two main things. Like one is image processing, and another is OpenCV. We'll be really coming into that each and everything. So first, let's take one at a time. So let's take image processing, the word. Again, it has two things, two words like image and then processing. So first of all, um, when you are operating with image, you need to know that what is actually image technically, how the image is represented, and what all the things that you need to know before playing with any kind of image. So overview of this talk is kind of like this. So first of all, we'll be discussing about what are the properties of an image. Then we will be going it onto what is image processing. Then we will look what is actually OpenCV, how it works, and then we will go with doing some hands-on with OpenCV, and doing some image transformations like cropping, blurring, resizing the images, or sharpening the images, and all those things. Then we will be looking at one of the algorithms that people use for edge detection of any image. So uh, uh, we'll be looking at Canny Edge detector algorithm, how it works, and how it how you can use it. We will also be doing hands-on for that. Lastly, we would also looking how you can extract a text from the image. If there is any text in the image, then how you can read it, how you can modify it, or how you can interpret it. So all these things will be covering. So first of all, I said that mm, what is an image, right? So the main question first comes is what is an image. So the people who have joined us, uh, let's make it very interactive, and let's go in the comments and just write it down what you feel, what is an image according to you. So I'll wait for some time, and we'll take some of the answers from the comment section as well. So let's just go ahead in the comments and write down what is actually you feel, what is an image, how you can define an image. We'll take 1 minute for this. Okay. Okay, so we have a few answers like Manmik is saying it is an array of RGB colors. Impressive, correct. Uh, Amlan is saying it is a JPG format. But JPG format again, you have PNG format, you have WebP, you have SVG, all these come under image only, right? So yeah, major of the answers that are coming is array of BRG or yeah, BRG colors. So yes, guys, you are correct. So it is an array. So image is basically an array. And what kind of array? So it is a three-dimensional array ranging between 0 to 255. So whenever you just go ahead and go to Google and check that color picker, so it in the bottom asks you about the three values in comma separated, that is RGB values. So you can represent any of the colored image in the format of RGB. And there are also types of image, which is binary. Then another is black and white format. Then you have a 8-bit color format and 16-bit color format as well. So these are all the types of images. Binary deals with, you all know that it is 0 and 1. Black and white is kind of a grayscale, and 8-bit color and 16-bit color format. So RGB basically deals with the 16-bit color format. So yeah, RGB, let's say this is an array of 72, 99, 243. So this is actually a value of a pixel, and image is collection of many such pixels, right? So the first value 72 is the value of R, that is red, then G, then followed by B. So if you take a value of a pixel and if you are observing this value, so we can say that the pixel means this pixel is actually a more of a bluish color, rather than it is more of blue in that pixel rather than it is red or green. So this is how it is represented. So for any image, it is divided into many pixels, and if you pick any of the pixels, you get a RGB value, and according to that you can understand that what is actually the color of that pixel, what it actually has more shade of. So having said that, we knew what actually image is. We got to know what image is actually technically, and what is pixels, and how image is formed with pixels. So let's move ahead with image processing and then OpenCV. So when we encounter image processing, we have to deal with couple of terms, which are like these fields. So it says computer vision, digital image processing, artificial intelligence, and computer graphics, right? So you would be noticing that OpenCV, so CV stands for a computer vision. So one of the things that when we encounter with image processing is computer vision. So it basically deals with images. Next thing is the digital image processing. So again, you kind of have an input of image, and then again, image is also one of the output. So that comes under the digital image processing. I'll be explaining it deeply, don't worry. Next is artificial intelligence, which kind of deals with the features and the functionalities of each and every image and corresponding to that, and again we have computer graphics. So this is what actually help you to understand what actually these four terms are. So just consider that we have an input that is on the left hand side, and on the top of the side we have mentioned it is an output, right? So if we go block by block, your input is image and your output is also image. Then it is considered as the digital image processing. So if you have an input that is an image and you get a desired output in the format of image again, so that is a digital image processing. If we'll move to block two, which is a computer vision. So the input is kind of an image, and what you get as an output is kind of information or description about it. Let's say, searching by image gives you some of the website, some of the more information. So that is example of a computer vision as well. Then you have input in form of description, and output in form of image. So that is what actually is the Google search, the image search that you go. So it is a computer graphics. Then in the block 4, you have artificial intelligence, where you have description as the input, and again in the output you get a information as form of description. So this was basically the idea, main idea about this, because all these four terms are actually overlapping with each other. So it is very important to kind of clear out these things and not to mix everything up with like this is also image processing and this is also image processing. So computer vision, image processing, both are different thing. Again, the artificial intelligence and computer graphics, both are different thing. So just need to be clear that how all these fields are focusing on the same thing, that is image, but again the functionalities and the usage is different, right? So next is we jump to OpenCV. So, anyone knows what is actually OpenCV? I would look for some of the answers in the comment section. Anything about OpenCV would be okay. No worries. Okay, so open source library. I have the answer. It is a Python or C++ library for image processing. Okay, an open source image processing library or module. Correct. Library for image processing. So yes, most of you are correct. And if we look at the answer, so most of you are going towards the answer contains the word image processing, right? So basically, the OpenCV is a open source computer vision and also a machine learning software library that helps you, which has over 2,500 optimized algorithms that you can use to set both kind of for machine learning algorithms, and then you have some of the operations that you can do with the computer vision as well. Basically, the OpenCV is written in C++, but it is used in it supports actually Python. It supports Java also, and C++ as well. So it was originally developed by Intel, and now it is taken forward by Willow Garage. That is also one of the organization. So moving ahead of OpenCV now. Uh, what other so you said everyone in the comments said that it is a open source image processing library and similar answers, right? So what do you think, like what are the applications that you see with the OpenCV? What you know kind of think that yes, this is actually built on top of OpenCV or using OpenCV uh, in your day-to-day life? There are many such things. I'll be moving to next slide, but before that, let's hear from you that what you guys think, what actually is are the applications for OpenCV. Let's go to the comment section for the answer. Okay, face recognition in our phones, correct. Photoshop, nice. Google Lens, yeah, absolutely. So, any more answers? Object detection, okay. Object detection is also one of the applications, right? So, I guess we don't have. I have made autonomous RC car with OpenCV. That's awesome, Marmik. That's really awesome. So yeah, these are the applications. So X-rays in the field of medical. If you see, so you have X-rays that are being here. One of the applications with OpenCV as well. Then object detection, as you said. The line following robot is one of the applications. Then we have fingerprint sensor that works accordingly with the OpenCV, and also one more thing which is quite a few quite a few. It's now being very common within a few years. That is a remote sensing. So also we can see that there is one photo that I have added here which focuses on the remote sensing of the images of the earth, the lands. It is also one of the applications that are used with OpenCV as well. Okay, so now next thing, yeah, let's get our hands dirty with OpenCV. So now we just this is more of a theoretical part that I covered, and now let's kind of jump to the practical and see how it is working. So let me share my screen again. Okay, so what I'm using here is the Google Colab, which actually comes up with OpenCV installed and Python runtime also. So yeah, first of all, how you install OpenCV into your machine. So the command is same, and when you are working with OpenCV, just a minute. Okay, yeah. So the prerequisite is you should have Python in your system. Python 3 is much favorable. And so you can install OpenCV using this command pip install opencv-python, which actually helps you. So for Colab, you don't need it because you can see the request is already satisfied. That means the Colab environment comes up with OpenCV pre-installed. Now, these are the libraries that you would be needing for these things. So first thing is import CV2. CV2 is the module that we use for the OpenCV. Next, I have used OS, in import OS. So I'll explain you why I've used it. Numpy is there, which we'll be using for sharpening the images and also blurring the images. We'll be using Numpys. Then this is something new, which is only for if you are using Google Colab. So basically, when you read an image using OpenCV and then you have to display an image, so you use a method called cv2.imshow. But Colab has its own built-in method for that, because there are some issues that are with that method cv2.imshow. So Colab comes up with its own module, that is cv2 underscore imshow. So I've imported it as well, and I have imported matplotlib, which helps me to plot a graph for the image part, right? So yeah, the image I'll be using is of a Thanos Avengers Infinity JPG. So it is here, right here. So Thanos and Avengers Infinity .jpg. So I have pasted the path in a variable which is an image path, and yeah. So now the game begins. So reading an image using OpenCV. So how you read an image? So there is a method cv2.imread, and inside that you have to pass the path of the image, and the image will be stored in the variable that you use. So I let me so this is the colored image part, and cv2 underscore im show, that I said that I have imported this here, which helps you to display the imported image or display any kind of image that you use in the OpenCV. And I have print a shape of the image that will display the height and width of the image. So let me run this part only. So yeah, this is the image that I've used of Thanos, and below this you can see here. Let me quite zoom a bit so that you can see it properly. Okay, so it is of 443 cross 760 pixels. The dimensions is 443 cross 760, right? So this is the image, and this image can be seen only by this block of code. So you use, again I'm repeating it, so cv2, using cv2 module, you can import, you can use this method imread, and inside that you have the image path. You have to pass the image path, and using the cv2 underscore imshow, which is provided by the Google Colab environment, you can display this image, and the using the shape property of image, you can display the height and width of this image. So this is the colored image, right? Now if you want that this colored image needs to be grayscale, that means you want this image in the black and white format. So what you need to do, you just need to pass one flag here as 0, 1 or 2, right? So it has, the imread has three kind of flags. That is, either you can import it with normal colored image which has a flag of 1. Also there are few flags defined, that like cv2 dot b2g grayscale, b2g original. So these are kind of flags. You can always read it online, but I prefer to use flags with the numbers. Those are been denoted by 0 and 1 as well. So 0 is for grayscale, and by default if you don't pass this, like here I haven't passed any flag, so by default it takes as a colored image, which is a flag of 1. So if I just pass flag 0, the image would be grayscaled like this. And yes, you can see the dimensions here below, 443 cross 760. So just one flag, and you can change the image from colored image to grayscale image. So this was all about how you can um, do with importing an image and then displaying it, converting the normal image into the grayscale image. So yeah, you said that in the beginning when we discuss about the image, like what is actually image. So everyone said that it is an array, right? So when import it, and you can check the type of that image, you can see here that it is numpy of n dimension array, nd array, that is n dimensional array. So I have used this image here, right? And I have checked the type of the image here. It says it is a numpy array of n dimension, right? So for a grayscale image, basically you will see a two-dimensional array, and it will be a two-dimensional array, and for the colored image it will be a 3D three-dimensional array. Okay, so next thing is calculating the size of the image. If you want to calculate the size of an image, so uh, I've just shown here. However, it doesn't use any kind of OpenCV concepts or OpenCV, what we can say, OpenCV methods or modules. So I said earlier that I had imported OS in the import section. So here is what I've used is to get the path and to get the size of the image that is in the image path. So basically this is a method. You can make a Python method using a def keyword. So def is here. My method name is total underscore img underscore size, which takes an input of the path of the image, the path of the image that we have displayed here, initialized earlier in the first block. So this method takes the path of the image, and it gets the image size, and you will get it in bytes. So I have converted it into this MB. So when we run this part, it is 0.05 MB. So it is if I hover here, you can see that it is 51.06 KB image, the image here, this one. And this is 0.05 MB image, right? So this is one another thing that you can do with Python as well. So next we go with the image transformation, and the first thing that we'll be doing is the resizing the images. So again, so whenever you are dealing with the images with OpenCV, you have to read the image. So I've done that. Next thing is I have done this resizing with maintaining the aspect ratio. So maintaining the aspect ratio means that it has to be of proportion. The height and width has to be in proportion. So here 443 cross 760. If I am reducing the size of the image and resizing it, so the new size of the image has to be proportion, so that the old image, when resized, don't get distorted. Correct. So for that, I have used a scale percent, that I will be resizing this image to 60% of the original size. So my scale percent is 60, and accordingly I have used shape property to get the width. Shape of 1 gives me width and 0 gives me height, right? So I have decreased the size of the width and height by 60%. And to resize the image, I have used cv2.resize method. Like to read the image, you use cv2.imread. Again, cv2.resize is one another method that you can use to resize the image. So the first parameter that is taken is the raw image that you have read. The second will be the dimension that you have made with width and height, right? So and when we run this and then cv2 underscore I am show, it displays the image. So here is the image. You can see on the top that it was a big image, and I have right now resized it and I've made it small. So why do we resize the images, right? Like for example, you are a good you're a passionate photographer, and you have clicked your photograph for a good photograph, and it is kind of a 6 MB or 7 MB image, and kind of always fill some of the forms where you have a dimensions given that the image has to be in this much height and this much width and must not exceed the size of, let's say, 2 MB. And at that point of time you go and resize the image, decrease the pixels of the image so that the size also gets reduced. So the same thing you can do using this few lines of code. So original size, original dimension, let me zoom it so that you can see it properly. So the original dimension of the image was 443 cross 760, and now after reducing it to 60% scale, it has been 265 cross 456. But do notice here that the aspect ratio of this image remains constant because we have maintained the aspect ratio by using the scale factor. We have used the percentage. We have reduced the height and width both in the same ratio, that is the 60%. And due to this we have able to maintain the size of the aspect ratio of the image. So this was about resizing it with aspect ratio. Next thing is, if you want, you can resize it with your specific height and width. But for this, if you do this, then you have to compromise with the aspect ratio. Like, yeah. So just look at this original image, and I have set the image width and height to 350 and 450 pixel. So it becomes like this. So the original image was something different, and now it is kind of again kind of, you can say, the distorted, and the originality is not that well maintained. So due to it, when you resize any image, you try to resize it with proper aspect ratio. And just to demonstrate that this was made with 450 cross 350, you can see in the below here the dimensions are 450 cross 350 that we have passed here. So it resizes to that dimensions. Right. So this was all about resizing, how you can resize with aspect ratio, and how you can resize with your own custom width and custom height. Okay. So next thing is blurring an image. Okay. So 1 minute. Okay. So, yeah, blurring the image. We normally in OpenCV we have a method again module to use to blur an image, and that is called a Gaussian blur. So we use this CV to, like, we have used cv.imread, we have used cv.resize to resize the images, and to blur the image we use this Gaussian blur method, which is takes the raw image. This 7,7 is actually the gradient that we pass, the gradient of or the, you can say, the intensity of the image that we want to blur. And here the third flag is the intensity of that image that we want to maintain. So uh, like it takes many other parameters, but all the parameters are optional. So the main parameters are this image, the raw file. Then the second one is this 7,7 that I've passed, that is the kernel size. And the third one is 0, which is, the aspect, the what we say, um, the intensity of the image that we want to have it. So let's run this. Yeah, so we have, this is our original image, that we are using, and this is the blurred image that we got, transforming this, right? So there is one thing, like, always when you pass this as 7,7, it not need to be 7,7, but it has to be the combination of odd numbers. So please do take care of this, that while you're passing the aspect ratio, that it has to be sorry, the kernel size, that it has to be odd numbers. Okay, so if you want to increase the blurriness, you can, easily go ahead and pass it as 9,9, and it will be more blur. So let me do one thing. Let me, like, compare it again. Let's copy this, paste this, blur image one, make it as 7,7. Although you won't be, able to see more difference, but yeah, there will be something. Right. So let me, okay. I hope that it is visible, because I have reduced it. Let me, okay. One, yeah. So you can see that the top image here is less blurry compared to the, the bottom one. The reason being that both have different intensity, both have different intensities in the image. So and the scale factor is different for the blur. For this it is 7, and this is, for this it is 9. So you can see the difference. So as you go on increasing it in the odd numbers, you will again able to see more, either the image get more blurry, right? Okay, now let's say you have this image, and what I like about this image is this Thanos, what do you say, Garnet? I don't know actually. So I guess you say it as a Garnet, and sorry if I'm wrong. So I want to crop this part, right? I want to crop this part. How can I do it? So for this, you can crop an image, and here is the code. You have to read the image, very obvious. And in so as I said, that image becomes array, so you can filter out the part of image and store it into another variable using this. So how this works is, let me explain this part. The image array uh, takes in parameters like the x coordinate, from where you want to start the cropping, to the x plus h coordinate, where you want to end the cropping for x coordinate. Okay, sorry, I made a mistake here. Y comes first. So the y coordinate from where you want to start, and y plus, let's say, w. So first you have to define the y coordinate, from where you want to start and where you want to end the cropping, and then followed by the x coordinate start and x coordinate end. So this is kind of the format that you have to follow. Normally, when we write in, when we write in statistics, we write it as x comma y. But here in OpenCV, it is inverted. So you have to take care that y coordinate comes first, then followed by the x coordinate. So when we run this, we get these. This part will be cropped out. Okay, so from this image, we cropped out this part here. Fun, right? So yeah, till now what we have seen is we have resized the image. We have blurred the image with different intensities. We have resized with aspect ratio and also with the custom width. We have learned how we can, crop and part of image, crop the image, a part of image there. And now the thing is how you can rotate the image. Like uh, Thanos is the heads up. Thanos has its heads up, so I want to, invert it with angle of 300 degrees. So this happens. This is the original image, and I transformed it with an angle of 300. So how you can do it? So first of all, whenever you have an image, you need to in order to rotate the image, you need to get the center point of the image, and that is done. So let me explain here again. I am reading the image, and then I have the height and width stored of the image using the image dot shape property. Then calculating the center of the image, that is width by 2 and height by 2. So I have the center. Now we need to get a rotation matrix, right? So whenever we perform any operation to any image, there is change in image. That means there is a change in the array of that image is basically an array. So there is a change in that array as well. So we made the change, and with the center, we use the method get rotational matrix 2D, right? And there are parameters that we need to pass is the center points of from where we want to, with respect to the coordinates we want to rotate the image, the angle, how much we want to rotate it. So I've here used 300. I can use 90, so it will become inverted on the left hand side. Then this is one, which is the aspect of the image, the what we say, the intensity of the image is been passed. That is one. So we don't want to distort any image, so we pass it simple one. We want to keep it in the original form, right? So we have a matrix of the image when it gets rotated by this angle and with this intensity, right? Now to now we have to kind of let's say you have an image and now you have a matrix. So according to the matrix, you want the image to be transformed into the new image. So for that we use cv2.wrapAffine method, which takes three parameters. The one is the raw image. The second one is the matrix that we have transformed after the rotation. The third is the original height and width of the image that we calculated earlier here. So note that here, whenever you take any whenever you take any of like previously I mentioned that normally we write it as x comma y. Here we write it as width, then width comma height. So it has to be this format. Else the shape will be different for the image, right? So when you pass these three parameters and you show it, so yeah, this is how it gets transformed. Okay, so next thing is sharpening the image. Right. So why do you want to sharpen the image? So let me, okay, let's explain this and then I'll go to the PPT and explain you something which is very interesting. So the first thing when you want to sharpen is you want to apply a filter. Let's say this is my original image, and you cannot see these parts, like the golden part is not visible clearly, or it has some kind of blur effect, or it has some kind of more brightness, or it is more dull. In that case, what you want to do is you want to sharp that image so that it is more visible. So for that, we do is we make a sharpening filter. And sharpening filter is nothing but a small array, that is a 3D array that we use. So NP. So anyone remembers what is NP? So let me go on the top. So yeah, it is a NumPy. NumPy is again a library in the Python, so which helps you to manage some numerical stuffs in Python. And using that NP, I have created an array of these values. Okay, so let me arrange it so that you can see this properly. So this matrix is 0 minus 1 0 minus 1 5 minus 1 and 0 minus 1 0. So this is the sharpening filter that we have created in form of array, and we will be imposing this filter over the original image that we want to sharpen. Right. So the main thing, when we are preparing any when we prepare any sharpen filter, is that the sum of all the values here has to be even equal to 1. Right. So like you can see here minus 1 minus 1 minus 1 minus 1, so 5 minus 4 is 1. So whenever you create a filter, uh, the value has to be like even, that is 1. So we have this sharpening filter. So again, I'm not repeating this part because it's common for all. So loading the image and preparing the sharpening filter, and then we use cv2.filter 2D method with the parameters of image and the array of sharpening filter here. So when we run this, so you can see that okay, yeah, this is the original image. Let me, yeah. So this is on the top is the original image that we used, and in the bottom is it's the image that we have sharpened. So you can see the difference here, as I was telling, like this part, in the violet part, it's bit blurry, but here it's sharpened, and you can it's kind of visible clearly. Right. So for this purpose, we use the sharpening method. And also, let me now move back to my PPT. Okay, thank you. Okay, so let's go ahead for quickly and just look at what we have seen. So image transformation, we saw the colored and grayscale images, how you can transform the same image to colored and then transform it to grayscale. Then we saw how we blurred how we can blur an image, then cropping the image. Uh, then we saw how we can rotate the images, and lastly we saw how we can sharp the images. Okay, so now the next thing is edge detection with Canny Edge detection algorithm. So when we talk about edge detection, so the first thing is, why do we need edge detection algorithm to function? So in case of an audio, right, you have a background noise that you don't want to hear again. So what you do is you kind of want to remove that background noise. So if I say that image also has a noise, what you would say? Like uh, what let's have some comments from you guys. Let's what according to you is a noise in an image? Have you ever heard about noise in an image? Okay, so let me move ahead then. Okay, I have an answer. Huh, 10 pixels, okay. Grains in an image, okay. Random variation of brightness or color information. Okay, yeah, correct. Yes, random variation of brightness or color information. So the next slide actually depicts it, the noise in an image. So you can see both the images. Like on the left hand side, you have the image is not clear. What we normally humans see is, यार ये image clear नहीं है, it's very blurry, or there is some of the spots that I can see in the image, and the main object in the image is actually not visible properly. Whereas on the right hand side, we say yes, it has an even brightness that is needed, it has the sharpness that needs to be there, and all these stuffs. So noise in an image is, as someone said, that there is a imbalance of brightness or imbalance of the sharpness. So with this, there is a noise in an image, and before you know so for removing those kind of noise, the Canny Edge detection algorithms is very handy. So here is what all about Canny Edge detection, right? So it was a popular algorithm. It's even a popular algorithm, which was developed by John F. Canny. Yeah, John F. Canny, and uh, majorly it has many steps involved for edge detection. Here are the five mentioned. The first one is the noise reduction using Gaussian filter. So we saw that the Gaussian blur. So the similarly you have a Gaussian filter that the removes the noise from an image. Then it calculates the gradient across the horizontal and vertical axis. The third one is the maximum non-maximum suppression. That is that there are when you remove a noise or when you apply a filter, what happens is there are some pixels that may go overlap, or may go may dim because of any of the third property or the third pixel coming over it. So due to it, there are there in some cases you have more than one pixels at one place, or you can say that more than one pixels are getting duplicate at that position. So to remove those pixels, we use the non-maximum suppression to remove the falsy pixels there. Then third one is the threshold gradient. So why do we use that is, we have we have a lower scale and a upper scale gradient that we fix while we detect the edge. Because if you see an image, there are many pixels and every pixel has different kind of gradient. So when you want to detect a edge in the image, it has to be a specific, it has to have a specific gradient value, that between this two value I want the edges. And what it will does is, it will only take the consideration of those two gradients, and the excluding those and except above the boundaries, it will exclude all other gradients. So and the limit of that gradient, you can only see the edges of gradient that has been in that area that you mentioned, the lower and upper boundary. And the last one is edge tracking by hysteresis. So there are some when you kind of apply the threshold, the upper limit and lower limit, there are some weak edges that are kind of connected to strong edges but don't actually fall under the threshold that you have applied. So for that, we do this at the end. We track the each and every edges, and we remove the weak edges that, or you can say the weak edge that are associated with the strong edge, which is not in that threshold limit, right? So this is how Canny Edge detection works. And yeah, let me again go to my collab part and show you how it works. Okay, yeah. So for this, I have used Matplotlib. First, I have made a graph plot which is of 16 cross 16 edge. Again, I have used this. I am read to read the image, but this time I have read it in the format of grayscale, because Canny Edge detection works better and works best with the grayscale images. So it is always better when you are using, when you are want to detect the edges, it's better to convert the image into grayscale. Then to find the edge, as I said, that there is a lower gradient value and the upper gradient value. So between the gradient value of 100 and 200, we find the edges. So cv2.canny, as I explained, that there are 5 stages. So you can do each and every step manually, and you can set your own values and make your own kind of algorithms. But cv2 has its own method, which is cv2.canny, which helps you to do all the 5 stages and get you the edges of an image. And lastly, I am plotting it. So this plt.subplot 1 to 1. So let me first run this and let me explain this part after we have the output. Okay, so you can see that I have converted this image into different grayscale image, and then I have detected the edges between the gradient value of 100 and 200. So those only the edges with the gradient value are here. Like if you see here, it is dark, so the gradient value may be higher, right? So you don't have the edges that are in this part, while on the left hand side you have those the edges been detected, because, and this is because of this value 100 and 200, right? So yeah, let me explain you this subplot part. So how subplot part works is 1 to 1. So you can you can think it like plt dot subplot 1 comma 2 comma 1. So it is one whole graph, and it consists of one row. So this is one means one row, and two means two columns, And the third parameter here, one, actually defines that the position. So you have two columns and you have two positions to fill each and every graph, right? So on the first position, I have done plt.im show image. Image is my grayscale image, so this comes here. And 1 2 2 is again 1 comma 2 comma 2. So and there I have, plot the edges. So that comes here. So the main logic here was to place both the graphs in this position. So we that's why we use subplot here, right? So this is how the thing works for the edge detection. And yeah, we are just left with just one small part. So let me go to my uh, yeah. So yeah, this was what we saw, that original scale image and grayscale image, and then the edge detection, right? So the next and last part that we will be covering here in this session will be the extracting the text from the images. And how we do this is by optical character recognition, that is OCR. So OCR stands for the optical character recognition, and it has the sub process that are pre-processing the image, either by the resizing part, or sharpening, or making it blur, or detecting the edges, those kind of things. Then text localization, and the character segmentation, character recognition, and post processing. Although this is not actually the compulsory way that each and every one has to follow, but this is kind of considered as a standard way that you should follow while you are using OCR for your text to image transformation. So you can say that OCR is a system, kind of system, that takes a 2D image of a text, and that could be a machine printed written letter, or a handwritten text, or it can be an image that has some human and also the machine readable text format. So how this OCR works with OpenCV? So we have something that is called the Tesseract open source engine. So what is Tesseract? So Tesseract is an open source text recognition engine, and that was a project, that was a PhD project initially at HP Labs, and later it gained popularity because of it was developed so well, and HP released the own Tesseract open source software. But later on near about 2005 or 2006, Google developed its own Tesseract engine, which works under the algorithm and neural network architecture, which is called LSTM, that is long short term memory. So this was all about the Tesseract engine. And so how the Tesseract engine works is it converts the original image into the adaptive binarization, and it converts it into the binary image. Now, when you have a binary image, you have different words and you have different sentences. So you kind of do this, right? So now you detect the number of words, and accordingly there are some of the steps that are associated for recognition of words and lines. And finally in the output you get a document kind of thing, or text kind of thing. So let's quickly see the demonstration of that. Okay, yeah. So for using the Tesseract search engine, you first have to install this Tesseract into the Colab environment, and you can use either this sudo app Tesseract OCR, or you can go ahead with pip installed by Tesseract. Okay, so it's already satisfied, it says, because I have already installed it previous. Right now, first thing that you have to do is, either you want to convert the image into grayscale, or you can directly use this. So I have a image. Just a minute, let me show it, the image part. Okay, so this is the image that I had with me, that is png, and it has a lot of text here, right? And what I did was by Tesseract, and I used the method image to string, and I use this image adopt.png, and also you have an option to add the favorable language you want. Either you can go with French or Spanish or English. You can mention it here if you have different languages also. So what it will do is it will process that whole part that I mentioned in the PPT, the whole part, and then it will return text to you. And I have printed the text which is here at the bottom. So this is the image that you can see, and this is the text that is being read from this image. So this is how the PyTesseract works, and it helps you for the OCR. So this was all major about how you can uh, do this optical recognition. So yes, we have mostly done, and we have picked all the parts for this session. And I hope that you like the session a lot. If you have any questions, feel free to go ahead and answer it. And yeah, thank you so much. Thank you so much, everyone, for having me.
Thanks a lot, Bratin. It was indeed a great talk. So, to all the participants, if you have any questions, feel free to throw them in the chat section. It will be, very great. Yeah. So here comes one.
Okay.
Is there any
Mm-hmm.
possibility to increase the resolution of the image or extending the image?
Yes, you can. So what you can do is, the scale factor I mentioned was 60%, right? Now you can kind of increase it to 200 or 400%. So that will actually increase the size of the image. But yes, the resolution may vary, depend on the image part. Like if it is a JPG, then you will feel the distortion. For PNG and WebP formats or SVG, you can restore the resolution as well.
Right. So, can it extract text with different font size?
Yes,
I
it
think this
does. Yes,
is
it
for
can.
the
Yes,
yeah.
it can. Yeah, it
Yeah.
it can. So the OCR actually, it has nothing related to size or font size. Basically, it is built like to detect the font in the image, and it returns the text format, whatever it reads in the image.
Great. So I think most of the
Okay.
questions you have asked during the session itself. So okay, one another one.
Okay.
How the algorithm
Okay.
of converting grayscale image to color works?
How the algorithm of converting grayscale image to color works. Sorry, but I didn't get the question actually. Algorithm, it so basically, OpenCV has that method called IMRead, which actually enables you to read the image in two different formats. Like if you want to read it in a grayscale, then you have to pass the flag accordingly. And if you want to read it in original format, by default, it comes with flag 1, so it is a colored image. So if there is anything specific, please do let us know. Okay.
Any ideas
Any
for
ideas?
participants in the
Hmm.
upcoming hack?
Well, So I guess it's OpenCV and image processing is actually a big part that, and also it has so many things that you can do. I just went to the comments and saw that OCR is used in Cam Scanner. Kind of correct, but the Cam Scanner is the perfect person to explain yes it does or not, or it uses something different. But yeah, you can go ahead and make anything like filters. That is the Snapchat filters are something which I like. And you can if you ask me, I would say yeah, go ahead and make some Snapchat filters for people.
I think the next question is there. So its
Tesseract
Tesseract
is
is
not.
not 100% accurate. Can we improve it and how?
Okay, yeah, it's correct. Tesseract is not 100% accurate. So, as I said that there are, different process, the pre-processing of image, and then, you can go ahead with, there are something like text localization, then the character segmentation. So you can make up your own, what we say that your own algorithms, or you can make it more refined it on your way, how you can do the text localization or the character recognition. That can help to increase the efficiency of the model that you prepare.
Right. So I think questions are over. Okay.
Mm,
Thanks a
yeah.
lot for answering all those questions. It was really an amazing and entertaining session. All of the participants are not right now live, but shortly they will have full access to the recordings. Along with that, they will be able to ask question in the Ask the Speaker section in our Discord. So feel free to answer
Sure.
them there. Thanks a lot, Bratin. It was super amazing to have you. But yeah, one more thing. Would you like to, discuss with all of our hackers or the participants, what are the do's and don'ts of hackathon? As per my knowledge, you have also participated in hackathons. You know a bit about the same. Would like to share your experience or something?
Yes, so right. I have participate in three of the national level hackathons as well, and also Smart India hackathon. So the main problem what hackers face in the during the hacking time is they lose the focus after like 5 or 10 hours. If it is a 24-hour hackathon, no one expects that they will be working for the 24 hour, but they kind of work for 15 hours. So proper utilization of the time, being focused each and every minute is very important. If you are much dedicated, then I think definitely you can do it. And yeah, definitely looking forward to this Python week hackathon from 8 to 10. So yeah, excited to meet lots of young and cool ideas with Python as well.
Amazing. So those who don't know, I would also like to tell everybody that Bratin is also a co-organizer along with us at this Python week. So we'll be joining you there. Thanks once again, Bratin. Those were very valuable suggestions and would
Welcome.
surely help the hackers. Thank you.
Thank you so much. It was really a good experience to be here. Thank you.
Guys, please join us at the filler session, which will be hosted at 4:30. So I think we can host it right now. Right? Is Siddharth there with me? Okay, okay. So let's do one thing. We'll host this session at 4:30, and this is what we were talking about. It will be total fun time. There will be lots of funny questions. Along with that, I will be there to entertain you alongside. Okay. So wrapping up the this session, let's have the feedback form. So you might see here on my screen there is a feedback form shared. Do fill it out. It will be open for 15 minutes. This will be used to assign certificate of this session and won't be reopened again. Right? Don't forget to fill this. Thanks a lot, everyone, for joining in today. Hope to see you in the next filler session. Along with that, we have again Shubham Manna coming at 5 p.m. So do join us there as well. Thank you.